Welcome to lesson 4EE, calculating area or probability under the curve. What we're going to be doing, here are your calculator rules and what you're going to do. We're going to actually now be calculating, since we know the z-score number on the number line. What we want to calculate now is how much area is being represented. So, for example, we already know, these again are rules for you to read when I'm not there. So we're talking about our basic bell curve. Now, just for a review, how much information is between negative 1 and positive 1? Hands up, please. How much information is between negative 1 and positive 1? How much do they say? Good, 68.3% between negative 1 and positive 1. Now, how much then if I extend it to negative 2, positive 2? How much information is between negative 2 to positive 2? 95, good. So, negative 2 to positive 2 is 95.4%. What if I extend that again? Now to negative 3 to positive 3, how much information? 99.7, good. So, 99.7% of the data. So what we're going to be actually calculating is we're not going to be given these beautiful z-scores all the time. This is a general analysis of the regions. However, what we're going to be finding is with real-life problem-solving situations, we're going to be finding, we might find a z-score of your math to be negative 0.6. So maybe it's right there. And we're comparing that to maybe your social exam, which maybe you had a positive 1.2. And you want to know how much data is in between those numbers. That's what we're going to be finding out, okay? And again, the calculator is going to be telling us. So, all of the area under the curve, from left to right, okay, is considered to be from 0 to 1, okay? So, starting on the left, it's like running a race. The left-hand side is the start. The right-hand side, where I've drawn this big, long blue line, that's the ending of your finish race, okay? So, when we're talking about deciding how much information, we have to find out what regions of the diagram they're talking about. If they talk about below the mean, we're talking about the left half of 0. We're talking about everything to the left of 0. We're talking about the mean, we're talking about everything above the mean. Now, how much information is above the mean? 50%, exactly. If 100% is all of it, and I said I wanted half, each side has to be 50%. Now, these are all percentage numbers, but when we talk probability, probability is not percent. Okay? Probability is always the decimal number before you multiply by 100 to get a percent. So, this is the way we're going to solve a situation. So, if you have only one z-score, what we do is we find the region. So we use either the outer left region or the outer right region. Now, on our z-score number line, our number line is going from negative 5 to positive 5. Those are considered our outer boundaries, okay? So, it's telling you right here, the outer boundaries have been given z-score values, negative 5 on the left and positive 5 on the right. That's what I'm talking about with my diagram up on the top, okay? So, when we have a diagram here, we want to shade the regions and we want to find out what they are. And we're going to have the calculator do it for us. Now, we're going to first of all decide, do we know the region it's talking about? So what we've got to do is we've got to find the z-score number first. So I'm at a z-score of negative 2. The middle is always 0. So negative 2 is going to be pushed quite far to the outside. So if I place negative 2 there, now it's saying, what information does it want? Does it want all the information above that number or below that number? Well, look at the way the inequality sign is pointing. The way it's pointing right there, this guy right here, he's pointing to the left. So since he's pointing to the left, that's the way it's going to point. So I'm shading to that direction. So I'm shading to the left. Okay? So that's a very tiny region that's shaded. So I won't find very much information over there. So let's go to our calculator now. And this is what that other page said to us. This is how we punch in our calculator. So we are now going to, almost everything we've done in our calculator has been with our stats. Now we're going to be using our two buttons down here, one called program and one called bars. Right above them, one says draw and one says distribution. We want the distribution. So we're going to go second bars, and we want number 2. Okay, second bars, number 2. Enter. Now, if you get what's called a left region, okay, you're going to get a lower. Some calculator screens show you this. Lower, upper, and then it shows you mean is 0, standard deviation is 1, and then it says paste. Okay, you might see that. If that's your calculator, that's okay. All you're doing now, in your lower boundary, you're putting the farthest left boundary. Upper boundary, you're putting your farthest right boundary that they've told us. Well, if we're shading this portion right here, we always use the outer boundary on the left is -5. So we're shading the information from -5 to -2. So our lower boundary is -5, our upper boundary is -2. If you've got the calculator like mine, where it just shows the normal CDF with it blinking like that, you need to put a comma between the numbers. So you're going to hit -5, comma, -2. So -5, comma, -2. Now it's going to tell us how much information is there. So we have 0 point, we always go to 4 decimal places, 0.227. So we get an area of 0.0227. Okay, that's to 4 decimal places. That's the area or probability. That means how much I have shaded. Now we want the percentage. How would I change that to a percentage? Times it by 100. Good. So the percent of data is 2.27%. So as we know, since most of the data is between -1 and +1, 68%, we should have very little information over there. Okay? And that's confirming that we do have very little information over there. Okay? So we get 0.0227 is our probability, or the area. Area means the same thing as probability. Okay, area just means how much was shaded. Probability means give you the number that was shaded. Okay, to describe the area. Now we're going to look at the very next one. What is the next one asking us to shade? Okay, I'm starting at +2 over here. Actually, +2 is further. It's way further right. So I'm going to put +2 way over on the right where it probably is. So there's my +2. Now where is it asking me to shade? To the left. So that means everything over here. So what's my left boundary then? -5. It stays -5 because I shaded everything to the left. So I have a -5 boundary, and now my right boundary, the upper one, is +2. Okay? So in my calculator now, I don't want to retype all those buttons. So you're going to do something different in your calculator. It's called second enter. If you hit second enter, it'll retype what you just typed. Okay? It'll back it up a step. So now you just have to move your cursor over, delete the negative sign, and now we have our answer. So we've got 0.9772. So this guy is 0.9772. That's how much area or probability is there. That's how much is shaded. Now the percent that is shaded, how much is our percentage? Good. So 97.72% is shaded. Okay? All right. What are we shading on the third example, letter C? Where am I starting and where do I shade? I'm going to start where? +1. Okay, let me locate +1. There he is. Now what? To the left. Good. We're shading everything to the left again. Okay. Now, that's going to be our lower boundary is a -5. What's our upper boundary then? +1. Good. Let's go to our calculator. I'm going to hit second enter. -5 is still my left. My right is 1. 84.13. So we should get 0.8413 is our probability or area. The percent times by 100, 84.13% is shaded. Okay, so that's how much data is on that section. All right. So, second bars. Okay, all of our data is in second bars. Let's take a look at the next 6 examples, because they're going to be a little different with some of our rules. So this one is asking us to shade from -2.15 to the left. So again, that's way over here to the left. It's a very small region that I'm shading. So let's find the area / probability. Going to our calculator, how big's my left boundary? -5. What's my right boundary? -2.15. Okay? We type it in, and it's a teeny weeny region. We get, and again, you're rounding to 4 decimal places always, 0.0158, because those 7s will round this last 7 to an 8. So that's how much is in that region. That's how much data. That's very little data. Now we're going to times it by 100 and find out how much is there. The percent is 1.58% of the data is shaded. So again, it's a small region. It should be a very tiny number. Now what is letter E telling us to do?
Shade everything.
Good. Shade everything to the right of -2.15. Do I have to even do the question? What do you notice about D and E? They're the exact opposites. If they're the exact opposites, that means if I put both diagrams together, the whole diagram will be shaded. And what is a full diagram shaded total? 100% or 1.0 for probability. So if I want to find this guy's area, I'm going to take 1.0 and subtract the area from this guy, 0.0158. Now we can put it in our calculator, and I'm going to show you how to do that in a moment. Now when we do that, we're going to get 0.9842. And our calculator is going to give us that exact same number in a moment. So that's going to give us 98.42% of the data. So let's make our calculator do it. So now, I'm going to clear it. Second enter. Let's type over our numbers. So, what is my left boundary? -2.15. That's way over here. -2.15 is my outer boundary on the left. If I need an outer boundary on the right, what's my outer boundary on the right? +5. Good. So now in our calculators, we're going to use our -2.15 as our left boundary. So it's going to be your lower boundary. And then your upper boundary is going to be your right, the 5. So (5). Enter. It gives us the exact same answer. Okay? Now that works for these 2 examples specifically because they're completely opposite. Okay? And they would, if you added them together on one diagram, you'd shade an entire diagram. Now what do you know about letter F? Right. Does it want me to shade to the left of that number, to the right of that number? What does it want me to do? Shade in between them. Perfect. So I need to find -2.15, +2.15, and I'm going to shade all the information between them. Now, we know that between -2 and +2, we get 95.4% of data. So this number I'm getting should be more than 95% because my numbers are a little bit bigger than 2 and -2. So let's take a look and make sure. So second enter again. Put my numbers. My left boundary is -0.215 and now +2.15. Enter. And it's greater than 95%, which it should be. It's 96.84%. So our area Probability is 0.9684, which is 96.84% shaded. Okay? That's how much data is in that region. Letter G. Where am I shading on letter G? To the left or to the right of positive 0.92? To the right of it. You always got to go with where this sign is pointing. It's pointing to the right. So you're going to shade to the right of 0.92. So I'm going to shade all that information right there. Okay? And now we're going to use our calculator again and ask us to tell us our left boundary now is what number? Yeah, 0.92. So 0.92, comma, 5. So we're going right to the edge, right to positive 5. Enter. So we get, let's just raise this up a little bit so you guys back can see a little better. So this guy is going to give us an area of 0.1788. That's 7 will round up, which is equal to 17.88% of the data. Okay? You guys try the last two, H and I right there, and then I'll check you in a moment, okay? Push pause now and play when you're ready. Okay, so let's take a look at what you guys have figured out. So the very first one there on letter H, we're on the positive side of 0, and we are going to be shading all the way to the left. So positive 2 is probably straight to the edge, and we're going all the way to the other side. On our calculator, it gave us an area of 0.9812, which is a percentage of 98.12%. Okay? Let's see what you got for letter I. It's a very tiny region. You're at negative 1.75 and negative 1.02. So it's a tiny region in there, just a little sliver. And the area you get is 0.1138, which is 11.38% of the data. Okay? So that's shading with your z-scores given. So remember, the z-scores go from negative 5 to positive 5 because we're going on the number line, right? So the z-score number line that matches this guy. Move my bottom line over. So we're going from negative 5, 0 to positive 5. This is our z-score number line, okay? And this is the number line we need to compare other items. That's why we need to use this. So now what we're going to do is we're going to work backwards. On the bottom of your page, or at the top of the next page, it tells us that now they're going to give us how much portion was shaded, and we have to figure out where the z-score numbers are located. Okay? So let's take a look. If you work backwards, all we're doing is hitting a different button in our calculators. So we are now going to hit again second bars, but instead of number 2, we're going to number 3, inverse norm. Inverse norm, inverse is opposite. So it's doing the opposite of what we were just doing. So number 3, we want inverse norm. I'll just clear my page here actually. So second bars, number 3. Okay, inverse norm. Now, when you have that, you might have area and then mean and standard deviation. So one of the other calculators, depending on the calculator you have, if it doesn't look like mine, it might look like this other screen that comes up that says area equals, and then it says mean is 0, standard deviation is 1, and then paste. Okay? If that's what it is, the area you want is the shaded portion they're giving you. However, remember, it can never, ever be given in the percentage. The percentage must be changed to the decimal. So, all percentages must divide by 100. So the number we're using here is 0.1762. And the reason we can use that number is because we read a graph left to right. And so, like I said, it's like starting a race. You have to start your race on the left, and you go until you hit your z-score line. So that's how much region I'm going through. So that's the region I have. Now I'm going to my calculator. So now I'm going to type in where I have the inverse norm. I'm going to type in 0.1762, comma 0, comma 1. If you don't have that other one that says area, mean, standard deviation, paste, if you don't have that, you need to put the comma 0, comma 1 on. You don't need to close your bracket, but you do need comma 0, comma 1. Always at the end. That'll never change. Enter. That's going to tell us how much percentage data is in there. So it tells us how much, or sorry, our z-score number. That's our z-score. Now remember, z-scores go from -5 to +5. So is it logical that we should have a negative number on the left of 0? A negative number on the left of 0 makes sense. So our negative answer here makes sense. So we're getting a negative z-score, and z-scores go to 2 decimal places. That's why they have hundredth here. So Z1 in this case is equal to negative 0.93. Okay? Now remember, on this Z-score line, each interval is not exact. So for example, on a normal number line that we have, our intervals have exact spacing, right? Every interval has exact spacing. That does not count on a normal distribution bell curve. How come? Because if we take a look at the normal distribution bell curve, most of our data is between -1 and +1, which is 68%. So that means they push -1 and +1 to the edges. That's why the middle region is so big. Okay? So once it pushes it to the edges, these parts on the edge are now equal intervals. But between 0 and -1 and 0 and +1, it's not an equal interval with the smaller ones on the edges. You have to know that. Okay? These are going to be 5 times bigger than these ones here. Okay? As a rough estimate. Okay, let's look at the next one, letter B. How is B different from A? It's positive and the shading's on the other side of the diagram. But we still shade and, we write our equations, and we have to find our region starting from the left. So we need to start from the left and go up to the line. So we need to know how much we're actually going through. Like I said, think of it as a race. You need to know how much space you have already traveled through. So again, this is where we know that the whole area under the curve adds to how big? 100% or 1.0. So I'm going to take 100% and I'm going to minus that percentage. That's going to give me the region I have to run through. That's the region we have to calculate. So when I subtract them, I'm going to get 85.08%. Now, again, I've got to divide by 100 because you need to have that in decimal form. So 0.8508. And yes, you need 4 decimal places. So let me recap what we've just done. We have to start from the beginning. We can't just start from the middle of the diagram. We start from the left, and we have to travel until we hit the z-score line we're trying to calculate. So that means the whole region that I have to travel through to get to that line, I have to know how much area that is, because I've already traveled through there. So that means I had to calculate that area. They only gave me this area. That's okay. I just subtracted. So now I'm going to use this number here in my inverse norm. So I'm going to show you what happens if you don't. If you use the other number, I'll show you what happens. So inverse norm, second enter, and now I'm going to retype my 4-digit number. 0.8508, comma 0, comma 1. Enter. I get a positive z-score of 1.04. So this z-score right here, z equals 1.04. Okay? 1.04. Now let's see what happens if I put in this number instead of this number. What do you think is going to happen? Any ideas? It'll be the exact negative value. Let's try that in a moment. I'll address your question in a sec. So let's just take a look at this guy. Let's put that other number in. And it's 1492. enter. It gives us the negative value. Okay? So if you understand that concept that it's just going to give you the opposite number, that's okay. Then you could find the answer with this one and just take the negative off. That's okay. You could do that if you understand the concept. Okay? But it doesn't work for every situation. That's why you have to know you have to start from the front and work to the edge. Okay? Let's try another example. All right, letter C. Now the reason they have shown us how much is shaded there is to help us find out how much is shaded until we get to our line. Because remember, we have to find out from left to the z-score line. So I need to calculate this whole region here. But they didn't give me all of it. They only gave me that piece. Well, what am I going to add to that? Well, I'm not going to times it by 2. How much data is on one side of the graph? 50%. So how much is that as a decimal? 0.5. So that means there's 0.5 data here and 0.5 data on the right. But they didn't shade 0.5 on the right. They only shaded the 2580. So we have to run through the other half of the diagram, though. You can't just start in the middle and go to the edge. You have to start on the far left. So that's why I have to include that 0.5. So now you're going to add those numbers together. So the number you're going to use is 0.7580. That's the number you're going to use for your inverse norm. So, again, in our calculator, second bars, number 3. And now I put in 0.7580, comma 0, comma 1. Where did I get the 7580? From 0.5 adding to the shaded area C. Okay? Good question. Okay, does everybody have that typed in correctly? We should now get 0. That's going to round up to 70. You always go to 2 decimal places, but this one's going to give us 70. So, we know that this z-score right there, z is at 0.70. Yes, we show the 0 at the end because they want 2 decimal places for a z-score. Okay, so that z-score there, z1 is 0.70. Letter D, we have 2 z-scores to find. When we've got 2 z-scores to find, we need to find the guy on the left first. So the way to find the guy on the left first, why do you think they gave us this part here that I'm shading? Why did they give us that? Any ideas, anybody? Okay, you're going to add it to this guy. Well, how can I find this part? I have to start at the front, right? I have to start at the front and run to the line. Nice. You subtract it from 0.5. So we're going to add those together and subtract from 0.5. That's why they gave us that other section, so that we know that all 3 sections are going to add to 0.5, because that's half of our graph. So I'm going to take 0.5 and subtract those other 2 numbers, 0.1292 and subtract 0.2145. That's going to be this first region. So our first region over here is $15.63. So 0.1563 is what we get. So this section right here I'm coloring in red is that 0.1563. Now we need that number because we start right here again on the left and we have to go to that first z-score line. So we go back to our calculator and we say second bars, number 3, inverse norm. We put in our decimal number, 0.1563, comma 0, comma 1. Enter. And it's a negative z-score, as it should be. So negative 1.1. Sorry, negative 1.01. So this first z-score is negative 1.01. Now we need the second z-score. How am I going to find the second z-score? Let me just erase some of this drawing up here so you can see what I'm doing next. How am I going to find the second z-score? Any ideas?
You add the subtract one to the first one.
Exactly. This subtracted amount we found, the 1563 for this first region we found here, we're going to add the first two sections. That's going to be our total we put in. All right, so we're going to add those first two sections, and we're going to get 3708. So 0.3708. So that's the number we use our calculator for. So now again, second enter, retypes everything, and now I just go up and type over my numbers. So I need 3708. Enter. Negative 0.33. So this guy's negative 0.33. Now, any idea how we could check our work? Any idea how we could check our work here?
See if they all add up to
Okay, you could add all three, see if they add to 50, but how do I know if these z-scores are correct that'll give me this shaded region? How do I know if they're going to give me 0.2145? We reverse it. Good. So we would go back and do what we did in our first step. So instead of going second bars number 3, we're going to go number 2, and we put in those z-score numbers. We put in the left one, negative 1.01, whoopsie, 0.01, comma, negative 0.33. And we should get the same answer as what's sitting right there. So we get positive 0.2145. 2145, yep, that's what they tell us right here. So that's how we can check our work and make sure we did everything correctly. Okay, you just work backwards. All right, we have two last ones we're going to do here. And then there's some practice time here coming. All right, let's take a look. Is there any confusion with the numbers here? Do we have to add or subtract anything to find our number? No, because they've shaded the region from the front right to the edge of our line when we need it. So they do have it shaded. So I don't have to do any adding or subtracting. I can go straight to my calculator. Second bar is number 3. And now I punch in 0.898, comma, 0, comma, 1. Enter. 1.27. So I get Z1, 1.27. Okay, I'll give you a minute. Okay, let's take a look at this last diagram. Am I going to use the number they gave me? No. Why did they give me that number then? To show me what's not shaded. So how do I find out what is shaded? Take 1.0 and subtract, because remember, the whole diagram adds to 1.0. So when I subtract it, I'm going to get 0.8729. Okay, which is very, very similar to 898. So I should get a number very similar to 1.27, because our numbers are not very far off. So let's take a look. Any guesses? Is this one going to be to the left of this z-score 1.27, or is it going to be to the right of it? Any guesses? Take a look and see how big this number is. Is this number I'm squiggling under, is that number bigger than the one shaded in yellow? Is that number bigger? No, it's not bigger. So that means this guy's z-score is not bigger than 1.27. Does that make sense? Okay, it's got to be to the left of that guy. So let's put it in our calculator and make sure. So we're going to go second bars, number 3, and we're putting in 0.8729, comma 0, comma 1. Enter. 1.14. We were right. So our z-score is 1.14. Okay? All right, the rest of the lesson is for you to practice. I want to show you one thing here. We can tell the calculator to actually draw the graph. So I want you to turn to page 26 in your notes. This is showing us if we have a window setting, we're going to put this window setting into our calculator right here. Okay, so everybody grab your calculator and we're going to put that window setting in. Okay, page 25, pardon me, sorry. Okay, top page 25. Yeah, top page 25. So we're going to put in negative 5, 5, 1. Negative 0.2, 0.5. And we're going to go up by, it should say 0.1, not 1 there. It should say 0.1. 0.1. So back to our calculator, 0.1. Okay, so we've got that in there. Now what we're going to do, we are going to use shade norm. We're going to draw some of these graphs. So we're going to draw the graph number 3. Let's see here. Let's draw graph D. Okay, we're going to draw graph D from page 24. Okay, so we're going to make sure we have that graph drawn. So all we need is the z-scores from that graph. So the z-scores we have from that graph are negative 1.01 and negative 0.33. So those are the z-scores we're going to use. Okay, so everybody with me? Okay, now we're going to go second bars, over to draw. Okay, we want number 1, and now we're going to hit negative 1.01, comma, negative 0.33. Okay, hit enter, and it's going to shade for us. Okay, it's a beautiful graph. So we're going to try that again. Everybody back to your main screen. We're going to go through it one more time slower. Okay? We're doing the steps that are shown here on the smartboard. So second bars. Use the right arrow over to draw. Number 1. And now we're putting in those z-scores. Negative 1.01, comma, negative 0.33. Enter. It shows us how much area is shaded, and it shades that region for us. Okay. Some calculators are going to have error functions. I will work with you with your calculator. Okay. You've got these questions to do for homework. We will take these questions up in about 10 minutes. Let's pause it now and play when you're ready. Record. Okay, you got a couple minutes? We take a look at the first one. You're going to shade from negative 1.83 to positive 2.65. It looks like it's going to be almost right off your graph when you do it in shade norm. So if you do this question here, numbers 1 to 5, can be done with second bars, normal CDF, number 2, or second bars, draw, shade norm. Okay, those are the ones that use these z-score numbers. Okay, and they'll show you the area. So the area or probability that's shaded is 0.9624, which is 96.24%. Over here, it's a tiny region that is being shaded. So you should have a section that's shaded at 0.0296. So very small regions shaded over here, so 2.96%. Moving up, this one says shade to the left at negative 1.6. Well, negative 1.6 is around there. So we're going to shade left. So we're going to go second bars, number 2, normal CDF. Our outer boundary is negative 5. So it's negative 5, comma, negative 1.6. And we're going to get an area of 0.0548. It's again a tiny, tiny region. Okay, so make sure you got it shaded correctly. This one, number 3 and 4, they're the opposites. Because this one wants to take and go from the negative 1.6. Now it wants it to the edge of the other one, which is positive 5. So how can I find this without really using my calculator steps? Subtract from 1.0. So I could subtract this number from 1.0 or use the calculator. You're going to get the exact same answer. So the probability is 0.9452. That's a 4. So 0.9452. So 94.52%. Yeah.
How do you know what to use, like, the error index from?
How do you know when to use
Like-
normal CDF or inverse norm?
Yeah, like, when you have 2, do you just put the decimal number?
What do you mean when you have 2?
Like,
Like number 5?
yeah.
Yes, when you have number 5, like on number 5 when they give you 2 Z-scores, you use both of those numbers. But if they don't give you 2 numbers, you have to find out which outer boundary they want you to shade to. If they want you to shade to the left boundary, you start with -5. If they want you to go to the edge of the far boundary, it's +5. So you always have 2 numbers no matter what. But if they only show you 1, that means the other number is either a +5 or a -5. Okay?
Okay.
Always.
So, because, like, on the first questions, right, you've got 2 of them, you only write down, like, the decimal numbers. Because, oh, I see, because there's an A.
Yes, this is saying it wants the area of this region. That's what it's saying. So my area, which is the same as probability, is this region. Okay? All right, we're doing the same thing on number 5. We're shading way to the edge, -3.5, all the way to +1. So it's going to look like almost the whole diagram's shaded, but it's only going to be 0.8411. So 84.11% of the data. Okay, the bottom of the diagram, I'll give you a minute to finish. Okay, before we find any information on any of these 4 graphs, we're going to find the missing regions. So, we find missing regions according to each section being half of the diagram's 0.5. So that gives me the ability to take half of my diagram here and subtract the shaded part. That's going to give me from the start until I get to my Z line. So the number I need is 0.2005. So that's the number I'm going to use with my inverse norm. So for this section, for all of these ones, when they give you the area, this second bar is number 3, inverse norm. So when I write my questions, I always write this. Inverse norm, and then I put my area, 0.2005, 0, 1, and then you get your Z-score. So your Z-score in this case is going to be -0.84. Now, we know it's going to be a negative number because he's to the left of 0, okay? And he's not pushed quite far to the edge, so he's going to be less than 1. Or sorry, I should say between 0 and 1. Okay, number 2. They gave us the region on the right-hand side, but we need to find from there till the line. So again, we know that 0.5 is over here. We change this to a decimal by dividing by 100. And then we're going to add those numbers because that's going to be my full region. So I'm going to have inverse norm, 0.898, 0, 1. And that's going to give you a Z-score of 1.27. Okay? So 1.27 is what you're going to get for that one. Just move that up for you. On the bottom question, they give us this region so that we can subtract them both from 0.5 to find this first region that we have to cross through. So when I subtract them, this red region I've shaded becomes 0.1423. So my first one for Z1, I do inverse norm, my first number, 0.1423, 0, 1. And I get Z1 is equal to -1.07. Now I try to find Z2. I'm going to move it up a little bit more. So when I try to find Z2 now, I need to add these 2 regions together. because those are the two regions I have to cross through. So Z2 is going to be inverse norm 0.3707. That's what I get when I add those two numbers together, comma 0, comma 1. And then you're going to have Z2 is equal to negative 0.33. And again, they're both negative Z-score numbers because they're left at 0. And we want numbers between negative 5 and positive 5. Switching to number 4, our last question. They gave us the diagram and they showed us this region so that we can add it to 0.5. So we're dividing each of these by 100 first so that I can get the decimal. So this is 0.1915 that I'm adding to there. So Z1 is inverse norm. I add these two together. So that's going to give me 0.6915, comma 0, comma 1. Z1, he's to the right of 0, so it's got to be a positive number. We get 0.5. To find Z2, I'm going to use my inverse norm again. And now I have to add my third digit, 0.1244. I need to add that number to my 0.6915. So I'm going to have 0.8159, comma 0, comma 1. And we get Z2 to equal 0.9. Okay, check your work. This is the end of lesson E.